Dear teachers and students, my name is Zheng Dongguo, and I'm from Hainan University. My advisor is Professor Yu Chongduan. The topic of my report today is the purpose-driven DIKW modeling and analysis of meteorology and depression. My report includes 4 parts: background, research content, research method, and summary. The first is the research background. There are many factors that include depression. Among them, seasonal and meteorological changes are important factors that include depression. Many scholars have carried out research and analysis on the correlation between meteorology and depression. However, the research conclusions of different scholars are often inconsistent and even contradictory to each other. Very few researchers have investigated the automatic identification and resolution of the inconsistent of the conclusions in different papers. We proposed purpose-driven DIKWP modeling and analysis of meteorology and depression. Different research conclusions can easily lead to confusion for readers. DIKW is the abbreviation of data, information, knowledge, and wisdom pyramid hierarchy, which has a long history of development and application. The second part is research content. The traditional knowledge graph construction method have problems such as insertion degree of objectification of subjective semantic, such as the sentence of large error in function of important origin can cause severe origin dysfunction, in which infection and origin dysfunction are identified entities. Exciting NER methods discard large area, series, and other contents, which may fundamentally change the original correct content, result in incomplete, inaccurate, and inconsistent knowledge, thereby misleading subsequent intelligent decision making. How to better to deal with incomplete, inaccurate, and inconsistent resource test is an open problem. Carry out DIKWP classification mapping on paper conclusion resources related to meteorology and depression, and construct a DIKWP model. The DIKWP model includes 5 levels: data, information, knowledge, wisdom, and purpose. Based on the subjective and objective cognitive process, we summarized the learning of knowledge into 2 parts: content content DIKWP and cognitive DIKWP. The combination of content and cognition result in a more complete semantic networks. This is the processing flow of the resource. The input is a paper on meteorology and depression, case E and case 2, which are characterized by consistent research content and inconsistent conclusion. We try to analyze the inconsistent paper from the perspective of DIKWP to output more correct conclusions. The third part is the research method. We propose to process language test modeling as data information, knowledge, wisdom, and purpose resources. First, the cognitive understanding of the reader for a paper and is unified as cognitive DIKWP. The content of the content of paper is uniformly expressed as content DIKWP, and then we map the content of paper conclusions with inconsistent conclusion to content DIKWP graph, including content data graph, content information graph, content knowledge graph, content wisdom graph, and content purpose graph. On this basis, we proposed a purpose-driven approach with text readers' subjective DIKWP as cognition DIKWP graph, including data cognitive graph, information cognitive graph, knowledge cognitive graph, wisdom cognitive graph, and purpose cognitive graph. Finally, based on the content DIKWP map and cognition DIKWP map, combining ontology, calculation, and reasoning, existence, calculation, and reasoning, and purpose calculation and reasoning, the subjective and objective semantic complement each other, get the semantic DIKWP that conforms to the cognitive semantic of the different readers, thereby reducing the impact of inconsistent, incomplete, inaccurate, and inaccessible resource, and effectively shortening the cognitive distance and reasoning distance. Based on the content and cognitive perspective of resource, modeling is carried out at 4 levels of data, information, knowledge, and wisdom. Firstly, the resources are divided into data resources and information resources according to part of speech and semantic. Secondly, the partial order relationship between data information and cross data information is determined according to the text grammar structure tree, such as HowNet, OneNet, and other open source conceptual semantic knowledge base. Thus, the content data graph the content information graph and cross data information graph are obtained by modeling, and then the content knowledge graph is automatically modeled according to the frequency and node in-out degree. Finally, the content purpose graph is obtained by modeling the content purpose. In addition, content DIKWP and reader cognitive DIKWP are mutually convertible, which is also an important mechanism for human learning. The modeling method proposed in this paper combine the data, information, and knowledge objectively contained in individual resources in a fine-grained manner, combined with subjective cognition. Content and cognition complement and improve each other, thus forming a relatively complete knowledge framework which can effectively elevate the problem of inconsistency in completeness, in accuracy, and inability to express individual resources. The first is the content. The first is the content graph of we have completed the conclusion of two papers on the calculation between meteorology and depression. One paper linked depression to high rainfall, where another suggests the opposite, leaving readers wondering. The first is the content graph construction process. We divide the content text into data words and information words through technologies such as AER and word segmentation, combined with a large-scale knowledge base. The partial order relationship between the two entities is obtained, and the data graph, information graph are constructed. The data graph and the information graph are mapped to a knowledge graph through certain knowledge rules. Furthermore, the knowledge mapped from the content express the author's writing purpose. In addition, wisdom comes from the application and the practice of knowledge by different people with different purpose. Cognitive semantic mapping is the reprocessing of data, information, knowledge, and purpose contained in the resources tested by readers, combined with their own cognition after receiving the objective resource test. Subjective cognition can supplement and perfect the incomplete, inaccuracy, and inconsistent objective resource test contents. A typical example is the guessing riddles. Only by combining subjective cognition and objective resource test content can be correct answer be obtained. Readers of different individuals can be with their subjective cognitive knowledge and subjective cognitive purpose to apply and practice knowledge and obtain cognitive wisdom graph with subjective cognitive characteristics. Finally, we proposed that objective content combined with subjective individual cognition of contents can obtain more complete semantic knowledge, carry out semantic retrieval according to the reader's purpose, and evaluate the completeness of case knowledge by qualifying the retrieval source. The fourth part is the conclusion. This paper is based on the analysis and modeling of the interdisciplinary correlation between meteorology and medical depression subjects and stakeholders. We uniformly map objective resource content into data, information, knowledge, wisdom, and purpose DIKWP content graphs, and map subjective stakeholders expertise in their mind into data, information, knowledge, wisdom, and purpose. We call DIKWP cognition graphs. Alongside the interaction from node of purpose graph to node among data graph, information graph, knowledge graph, and wisdom graph. Each combined DIKWP semantic graphs integrating DIKWP content graphs and DIKWP cognition graphs. We review the correction of the routines of DIKWP trajectory of reaching various conclusions in various research papers. In the future, with our DIKWP machine learning initiation, integrating data learning, information learning, knowledge learning, and wisdom learning, we expect to embrace DIKWP digital economy chain comprising data economy, information economy, knowledge economy, and wisdom economy, which are supported by trust DIKWP chain of trusted data, trusted information, trusted knowledge, trusted wisdom, with efficient and effective DIKWP governance chain. Data governance, information governance, knowledge governance, and wisdom governance. My report is over. Thank you.